In this video, we're going to show how to add custom tool scripts into the Uleska DevSecOps platform. The Uleska DevSecOps platform is extensible with any tooling that you need to put in. This could be dynamic testing, it could be static analysis of source code testing, something that's going to check your AWS or GCP configuration, etc. Really anything that you can write a script to test that can then be put into the Uleska system. This is extensible to increase the amount of coverage you can have in your software security tests, but also to allow security tests to be specific to the types of applications and the types of checks you want to do as an organization and as a team that don't come from off-the-shelf commercial or open source tests. To put custom tools into the Uleska system, there's really three stages. One, you got to create the script that's going to do the security test. We'll show how to do that. Secondly, you take that script and you wrap it in a Docker. And thirdly, you then configure the Uleska system to pick up that new Docker and run it as a custom test. So in step one, we've got an example Python script here that can be used to create a custom tool. We'll go through the creation of that now. First thing to notice is that we have imported some libraries, Python libraries created by Uleska in open source to allow you to more easily create these custom tools. They can be found on the Bitbucket site in an open source directory for Uleska. And essentially these really create or contain two main files. One is the vulnerability definition, which allows you to create an object in your Python, which is going to hold the taxonomy or definition of a security issue or vulnerability. And the second one is the formatter file, which takes those vulnerabilities and essentially writes them up in the correct format to an XML file, which allows it then to be ingested back into the main Uleska platform. So these have been included in our Python file. They've also on our Linux box been imported just into the directory we're working with. And in our script here, we're going to do a simple check that looks at a website, tries to access it without HTTPS, and checks if there's a redirection set up there to redirect the system up to HTTPS. This is something you commonly see on various security standards inside organizations. So the first thing to note is obviously our script is going to take some inputs. One is the URL that's to be tested. The second one, just for our script here, is a debug flag, whether we print out some extra debug information or not. And the third one is an output directory, which for us is going to be where the vulnerability XML file is written to inside the Docker. We'll show how to pass all these three arguments in a custom tool whenever we configure it later on inside the Uleska system. So then we come to the bit where we just have our simple text, our simple script, which is going to do some testing. We're going to take the Python requests. We're going to set up the URL by stripping out the S bit. So we're going to the HTTP portion of the domain in question. We're going to make a request to that, make sure we don't follow to redirect so we can see what the value returned is. I'm going to say if it returns a redirect, here simply we're going to say that's okay. Otherwise, we're going to flag up an error. Obviously, there could be more detail put into this test. This is just being used for an example. So if we get to the point where we think we have a vulnerability because we have not got a redirect, we can create this vulnerability object, which comes from the vulnerability we have loaded in previously from our library. That vulnerability object has certain fields, and this is essentially the definition of the taxonomy of the issue, where we have a title for the issue, a summary for the issue, an explanation, and a recommendation. These can obviously be refined to provide more information to the end users, to the developers, or the people using the Uleska system to view these issues, but these are just being used for examples. We also pass in the URL, the domain that's caused this issue. I'm going to pass in a severity, which is an enum. a CVSS score. Anybody unfamiliar with CVSS can use the first.org calculator to be able to understand the CVSS system and better calculate these and create these strings if necessary to put into the system. This allows the Uleska system to understand the severity at a technical level of the bug being returned back, and an MD5 flag for this particular issue. The MD5 flag doesn't need to be returned. If it's not, the Uleska system will take an amalgamation of the first 4 fields and combine those together to be a definition of the vulnerability. And essentially this allows then the Uleska system to categorize multiple instances of the same bug as the same category. However, sometimes this doesn't work if you want to put some variable text in here, such as codes or URLs or requests, etc. And if you're going to do that, it is better to place your MD5, a unique MD5 string in here so we can uniquely identify that particular type of vulnerability is going to be passed back. Then we add this vulnerability object into just a dictionary we've created. So here we've also got a debug flag. This is simply allowing us to print out some extra information about the information as it's going through. This is really being used as an example to show how to pass these debug flags and others. So here, essentially in these lines, we have some code in Python that is conducting a security check. This can be as simple or as complicated as is necessary. This could be calling other security tools, open source tools, OWASP tools. It could be calling APIs to existing security tools or commercial tools inside your organization. It really can be whatever you need it to be, as long as it's able to determine security issues, record those as vulnerability objects, and store them back in the system. Then that's what you can do inside your custom tool. We then use the Uleska save vulnerabilities to file function to take our lists of issue found and store them on the local disk as an XML file. And this is then what the Uleska platform will use to extract those vulnerabilities back into the main system. So at this point, we've created a simple custom tool, and we can run that to make sure it's going to work correctly. So if we run our command, we're going to be able to see this custom tool running. So through Python, we're going to run the Python file. We're going to give it example.com so we can test to see if that has an automatic redirect, which right now at this time of creation of this video, it doesn't. And we're going to just create an output file. So we've ran it, shown the inputs. It's made a request for the HTTP version, and it's failed to receive a redirect for that. So therefore, it's going to raise an issue. If we wanted to see slightly more information about that issue, we could run the same command, but with the debug flag set, and then that's going to print out slightly more information in terms of a debug. Again, this is an example version of creating these tools. So at this point, we have a custom tool which is able to develop issues based on the definition we have. And if we look at this output file, which is just created, we can confirm that it's able to create the XML file containing the title we had, the summary we had, other details, including the CVSS, etc. So at this point, we know we have a custom tool which is finding issues, that is able to write the file. What we now need to do is simply take that and wrap it inside a Docker. So to create the Docker, we have other information here. We have our requirements file. Since this is a simple test, we don't need much. We're simply going to download the open source Uleska library information for those Python libraries we wish to create, and just the request directory, so we can use that. We also have a simple Docker file here, which gives us our, based on Alpine, gives us our Python, takes our requirements to load in, and then copies our Python script that we were going to run and places it in the user source app directory. This allows us later on in the Uleska platform to be able to register where that particular Python custom tool is going to run from. So to wrap that into a Docker, we can simply give it our command to build the Docker file. So Docker build, we're going to call it HTTPS redirect checker v1 and use dot for the local Docker file in our system. So at this point, we're in stage 2. We're creating the Docker file and making sure it runs correctly as a Docker. We actually pass the same configuration, the same Docker creation configuration into the Uleska system. We don't pass the Docker file itself. So we've created that Docker. So what we can do now is just test that we have our system set up correctly to be able to run that. So Docker run, our Docker, and the command we're going to run is Python 3 HTTPS redirect checker with the URL and with the output directory. So we've confirmed that test is running fine when we run it via Docker command. So now we have this Docker information. We want to be able to put this information into the Uleska system so it can have the custom tool and be able to run it for any of the teams or any of the CI/CD pipelines that we want to run it through. So to prepare our custom tool for entry into the Uleska platform, we put all that information into a directory that we can then upload to the system. Just one note that we will create a simple PNG here so that the user interface of the Uleska system can display a picture for this particular tool. So if we go to our Uleska system, we click on the Custom Tools tab and click on Add New Custom Tool. Here we're going to give our custom tool a name. HTTP checker. Description. And then we're going to pass in some information to allow the Uleska system to recreate the Docker that contains the custom tool. So we're going to give it a picture for the file, for the custom tool. We're going to give it the source code. Now to give it the source code, what that essentially means is we have to take the requirements file and the Python file and put that into a zip. That's how the format this gets passed into. So we can now pass in that newly created zip. XML file location, we always keep a /user source app output.xml. This tells the Uleska main system that after it's spun up a Docker to run this custom tool and that custom tool has run, before it brings down that Docker, it will check for user source app output.xml for any registered vulnerabilities or issues found by that custom tool. This is how that is communicated between the spun up Docker file, Docker container, and the main Uleska system. We then pass the Docker file to allow the Uleska system to recreate the Docker. And we provided with the command that needs to be run. So this is the same command we ran before. However, in this case, we are going to make a change. We are going to pass the output directory as a text string. We also want to make sure this directory matches with this directory, because this is where the custom tool is going to write its XML file to. This is where the Uleska system is going to read its XML from. But in terms of the URL, we want this to be passed by the Uleska system itself. So what we do is we set this up to pretty much pass in the information that's passed by the into the Uleska project. So we type in scheme. That means whatever schema is used for this project, if it's dynamic, has been passed in here. And here we pass in our host. This means if we create a project and we put in a dynamic URL, this is going to provide those elements as this section. This makes it dynamic. It means you add the custom tool in one place, and as you add lots of different projects that are dynamically being created in lots of different places, it will automatically be checking the correct place. We'll see an example of that later on. In terms of tool type, there's really two, dynamic and static. Essentially, static is only used whenever you have a custom tool which is analyzing a source code, in which case the configured Git repository will be cloned onto that Docker as is created for the testing. Since we're not using any code, ours will be dynamic. And then lots of parameters can be created for a custom tool. These are configured as part of the toolkit whenever a project is set up, and we'll show this just with the debug flag. So we're going to create a new parameter. Oops. I'm going to call it debug. Flag that was passed into the custom tool, the Python script, was debug. Required, it's not required. Instead of being string, we have lots of different options here. We're actually going to take an option value, description. And what we're going to do is add values. True and false, and press tab or return to have those options checked. We'll have our default being set, default being set to false. We can save that parameter, and that's an option type we will then have. At this point then, we passed all the information in we need to the Uleska system to be able to create the custom tool. If you click the back button, and then you have the new tool here, you see it's incomplete, because what needs to happen now is you need to request approval, and then the administrator of the system needs to review and approve the source code and usage of the custom tool to be used in their system. So request approval, and that will go through to your admin. We won't cover in this video the admin steps to allow and approve those custom tools. That'll be done in a separate video only for admins. When the admin clicks approve for your custom tool, that will cause the Uleska platform to begin the process of creating the Docker image for your custom tool. This could take a few minutes depending on the size and nature of the custom tool Docker that is being created. Whenever the Uleska system has finished creating the Docker for your custom tool and everything has been a success, the tool will be approved in your system and is now can be used against projects. Just to note that earlier on we covered the schema and host parameters that can be passed in. These are passed in from your application version configuration. So here would be the schema, and here would be the host name, etc. Other elements that can't be passed in for various types of tools is the get address, authentication modes, login paths, required headers, as well as other information such as connections, cookies, and other headers, etc. See the Uleska documentation for more details. So now we'll create some applications and versions to use our new test. Specify where it's situated, 100 users, external, authenticated. And in our custom tests, we're going to create two versions. Going to be example, and we're going to make the URL https example.com. We're going to hit save and continue. And here, when we go to our test toolkits, we'll see the new test tool that we added in of HTTP checker. And we can add this tool. In fact, what we can do is set the configuration for the debug to be true. So of the 3 parameters we've passed into the original Python script, 1 is passed in as a literal string when we added the custom tool. The second one, the URL, dependent on the version information we passed in before there. And the third is dependent on the flag set here. And these are 3 different ways you can always pass parameters into these custom tools. So now we've set our custom checker, we've set the debug, and we can hit save to then allow that custom tool to run for that version we've created, which is example.com. So in the background, this is spinning up the new Docker we created, which has the Python script of the custom tool that we added in. It's passing in this information as well as the configuration we set through the cog when setting up the toolkit. And it's running that test. When it's completed running that test, the Python script is going to write any vulnerabilities to that XML file. And that XML file is going to be retrieved by the Uleska main platform after the Docker is completed to allow the vulnerabilities to be returned to the main database. Now that that test is finished, it is returned, as we expected, 1 vulnerability, and we can see that in the results. No HTTP redirect to the HTTPS, and we have the other fields we passed in: URL, the severity, summary, explanation, etc. We can, in the Uleska system, update this now, because even though we passed a CVSS, we haven't given this particular type of issue, which is brand new to the Uleska system, an ASVS. So we can do that by going through the list of ASVS categories we have here and finding the correct one. So we can use this one. If we save that, then it tells this what category it is. We go to full details. Now we'll see that it's SVS 911. If we look at the logs of the run, we can see that it's ran the output that we've printed the standard out for our custom tool. And it's also printed the debug information here. And then the information is printed to the XML file. If we go back to our application and we create another app, another version, this time we call it Uleska. We can give it a different URL. And we can save and continue that. Go to our test tools. And just note, custom tools can be run with other tools in these toolkits. Here, set this to true again. Make sure HTTP checker is added. We can now save. And we can run the same custom tool against a different project. And this time, it's going to take, again, the configuration information for this. It's going to take the fact that this URL is passed, or if this was a different type of test, it would take a different GET address or other login information, etc. And it's running the same tool with the new information. As we can see, the testing is completed. And since this website for Uleska does have a redirect, it hasn't returned any issues. Again, we can see the logs. and I can show that it's run, but successfully received a redirect. So it hasn't raised an issue. And this is how custom tools are passed into the Uleska system to be run as various checks inside your CI/CD pipeline and automated security tooling. The range of types of testing that can be put into these Python scripts is extensible, and go to the Uleska online documentation for more information about how information can be passed from the Uleska system into your custom scripts and how the information can be passed back.